Hello! I am going to explain how to set up your physics notebook. So, the first thing you need to do is click on the new sample slide link. So you're going to want to have that open, and then you can open up your actual notebook that has been created for you if you click under your work or my work or whatever it says on your screen. So I'm using a student's notebook and I'm going to show you the process. If I can get it. Okay, there we go. So the first thing you want to do is set up your table of contents. And the best way to do that would be to go to the sample notebook, click on the table of contents, click on the slide itself. So don't try to highlight this stuff, but just click on the slide itself and press Control-C. And then Control-V to paste it into your notebook. Then you'll be prompted with this. Click on Link to Original Presentation. That way, any changes that I make on the table of contents, which I'll show you real quick. So this is the sample notebook right now. Now on your own notebook, there we go. It'll have a little announcement. It says update, and then you can press update, and it'll update whatever I wrote on the sample. Here we go. Okay, so we're on the student one again. Once you have the table of contents, then go in and delete your old table of contents. And then you're gonna get a blank slide. Delete it. Oh, I think I just deleted the wrong one. What? There we go. So delete any of the blank slides. And then, okay, actually, this student was not in my class when I used the slip and slide application. That's what it's called, where I can enter slides into your notebook. And so I'm gonna have to copy slides a different way, which is fine. So I'm gonna go into the sample and I'm just gonna copy and paste each slide that I need. And I'm gonna say do not link because in this case, I need to do these slides on my own. But for the rest of you, you'll actually have the slides already there. You just need to organize them. So you might have to scroll all the way down to the bottom of your notebook and then delete the unwanted slides and then, sorry, one second, and then kind of rearrange them to move them up a bit. All right. So now let's compare our table of contents with what we actually have in our notebook. So the first slide is the collision predictions. And that was just that quick warm-up assignment where what you had to do was predict what would happen after these two blocks collided. So on the left-hand side, it's like before they collide, and then on the right-hand side, that's gonna be your prediction in what will happen when they hit each other. And so if this was a brand new slide, you would see some arrows over here that you can click and drag. You can also Control-C, Control-V to paste arrows. You can turn them around. And you could use that to help express what you think would happen. If you don't like the idea of using arrows, you can always just use a text box. So here's an example. I think the collision will result in the green block coming to rest and the this is for this one down here. And the double block moving more slowly than 2 meters per second. So you can use words, you can use arrows, you can use values, that is up to you. And you'll notice that if you kind of scroll to the side, you'll see there's some instructions here. So let me just zoom in on that real quick, or not zoom in, but increase the text size. So feel free to do that. You can modify the text so that it's legible for you. And that's it for slide number 1. Slide number 2 was the simulations. So this is the reorganized slide. We did this before, but the document itself was kind of hard to work with, so that's why I redid it. This one is filled out already, but I'm going to, let's see, I'm just going to run through it real quick, and I'll use the same settings. So let's say we have a mass of 1 kilogram for the red car, mass of 1 kilogram for a blue car. The initial velocity is 3 meters per second for the red car, and it's going to hit a blue car that has a velocity of 0 initially. So the simulation that you need to use is linked at the top. And this is what it looks like. So I'm going to set those initial conditions to match what the chart says. And for you, you don't, like, your chart should be blank, so you would fill in your own initial conditions. And okay, so I have the 1 kilogram mass for each of them. And then I said the initial velocity for the red car was 3. The initial velocity for the blue car was 0. Okay, so that is why I put initial velocity here, initial mass, or just mass, and then the other mass, 0 meters per second. And then calculating the momentum, well, that is just mass times velocity. So mass 1 times 3 velocity, 3 kilogram meters per second. That is the momentum for the red car initially before the collision. Do the same calculation for the blue car, except 1 times 0, and you get 0. The total momentum before the collision is just going to be 3 plus 0, or whatever your 2 momentum were, and then I get 3. So all of this section is done before you even run the simulation. Now I'll press start, and we wait until the collision occurs. There we go. Okay, so now I'm going to fill out my after collision data points. So we have the red car, of course, is still 1 kilogram. We have the blue car, still 1 kilogram. The velocity of the red car, you'll see it becomes 0. So we type 0 here. The momentum, 0 times 1 is just 0. And now for the blue car, the velocity is 3. Mass still 1, 3 times 1 is 3, and so the total momentum after the collision is 0 plus 3, which is 3 kilogram meters per second. So the overall change in the red car's momentum, well, it started off at 3 kilogram meters per second, and then it resulted in 0 kilogram meters per second. Calculating the change in momentum is just going to be 0 minus 3, or final momentum minus initial momentum, which gives us an overall change in momentum of negative 3 kilogram meters per second. Next, for the blue car, started off with the momentum of 0, resulted in a momentum of 3, final minus initial, 3 minus 0 is 3. All right, if we were to add those two changes in momentum together, negative 3 plus 3 is 0. If this whole section is confusing to you, I wouldn't mind if you deleted that. The whole point of this is that, was momentum conserved? And the answer is yes, it was conserved. Overall, the change in the momentum of the two cars before and after is 0. So there was no change. It started with 3, ended with 3. So in other words, the initial momentum was 3 and the final momentum was also 3. The second part of the simulation requires you to change just one main setting. You should adjust the mass. You should change a couple of things, but the main thing that I need to do is change this from an elastic collision to an inelastic collision. And so I'll just keep the same settings for now so you can get an idea. So red car starts at 3 meters per second, and when they collide, they are now stuck together, and they're moving with a total velocity as a unit of 1.5 meter per second. So the difference here when you're filling out your simulation chart would be the initial conditions are going to be exactly the same, like the same process, just fill out the data, but the final conditions are going to be, well, we don't have two separate masses anymore, we just have one mass, and we get the value for that by just adding the two separate masses together, because now they are moving as a single unit. Same idea for the velocity. So we no longer have two separate velocities to worry about, we just have their total velocity that they move together as a unit. And so the data here is for different initial condition set, so I'll just delete that. But that's essentially what you need to do, and the momentum should be conserved. You should see the initial momentum or the momentum before the collision should be equal to the momentum after the collision. All right, next page. And let's see, so the first two pages I have numbered already. Now I'm gonna number the next one. So this is gonna be entry number 3. And notice that these aren't page numbers or slide numbers, these are just entry numbers. So if you have multiple pages that you need to represent for just one entry, you can have multiple 3s if you want. The main thing is that we need to see what the entry number is. Alright, so for this, you'll enjoy this because it's very quick and easy. All you have to do is click on the link at the top of the page, and you'll be filling out these notes. Anywhere where there's a question mark, you're going to fill in information. So for example, momentum, we're looking for the variable, and here it is. The variable for momentum is P. So just erase the question mark, put the letter. Mass, the variable is M. Velocity, the variable is V. Then we have the units. Don't just gloss over these, actually read these. These are supposed to be your notes. So kilogram meters per second is the unit for momentum. But if we were going to be writing that on a problem, we would say, or we would write kilogram meter per second. And you could put like a multiplication symbol there if you want. I also accept it like this. So you'll continue on filling out this information. Let's see. Things like that. So just fill in the blank. Momentum is equal to mass times velocity. And then down here, we have a few different equations that we're trying to get familiar with. For this first equation, this is as though we have two separate objects, and we want to know their momentum before they collide, and then after they collide, well, those two objects stay separated, and so that would be like this. So this would be like an elastic collision, like this. Now, for this next one, we just have one velocity initially, and then I should have just put VI, not V1, but the initial velocity of these two objects together is equal to the mass times velocity 1 final. So this is kind of like this single object experienced some sort of explosion or something that resulted in that object splitting apart into two separate objects with their own unique velocities. So this would be an example of when the object splits. For this last one, we have two separate masses with velocities, and then afterward they get stuck together. So this is just like an inelastic collision when, let me speed this up so it goes quicker. There we go. So it's like they get stuck together and now move with a single velocity. All right, so that's entry number 3, and lastly, entry number 4. So each of these problems require you to highlight your givens, draw out a super simple picture that shows the before and after situation for each problem. I do not expect you to draw it on the Google slide. Unless you have a lot of patience, go for it, but it's totally fine if you just write it on a piece of paper. And then I recommend either trying to fit your answers in the right hand side, or if you want to just create another slide, take a picture of your work written on paper and then insert it onto the next slide. That would be perfectly fine. Now, if you refer to my sample notebook, I did put some example problems that I did. There's also an instructional video where I go over how to do some of these calculations. Let's see. Oh yeah, and then another really nice thing is that most of the problems have already been done and you just have to refer to this website to get help on them. So a lot of these have pictures drawn for you, and they also have solutions that are completely written out step by step and described. So I highly recommend, if you feel like you're getting stuck on this, check out the solutions, check your work there. And the only problem that I know for sure is not on the website, I have written out on my example notebook. So that would be number 7. Check out my example. I also posted something in the stream on Google Classroom about that. When you are done with your notebook, you don't ever have to press turn in here. As soon as you press turn in, I believe you lose access to it. So you don't want to do that because you want to have access to your notebook. What I'm doing is I'm assigning work through their own individual assignments. So if you, I'll try to do something to help you stay organized with this, but anytime that you're supposed to put something in your notebook, I'll try to make it very clear. But the 2 assignments that have gone into our notebook as of now are assignment number 2 and assignment number 5. And that's it. All right, last announcement, I guess. So on the front page of your notebook, you'll have a link to prompts and link to sample. If you just want to delete the link to prompts, that's fine with me. The main thing you need is a link to the sample. However, you'll see that there is a new sample slide link. So you will want to copy that and paste it into your notebook. If you want it to look like it's actually a button still, what you do is Control K, and it allows you to insert a link and apply that link to the shape there. So I'm going to link it to both the words and the outer shape. And since I'm picky, I'm also going to remove the underline there and then change this back to black. And there we go. Okay, that's it for the notebook.